So last class, we dealt with using technology to find the integral. What could we do if we don't want to use technology to find the exact value of the area? Is there a rule for it? Yes. It's by using antiderivatives, or more specifically, the fundamental theorem of calculus. So let's first talk about what an antiderivative is. We've learned about a derivative. Whenever you want to go from an equation, you find the derivative, which would be the velocity or the rate of change from that position function. Well, what an antiderivative do? Well, it'll calculate, this is the fundamental theorem of calculus, so I'm not there yet. It'll help us calculate the area under a curve. So here's the antiderivative. It's basically going the opposite of a derivative. The antiderivative is the opposite. So if f of x equals x to the power of n, then this is the symbol for antiderivative. That right here is the antiderivative symbol. Antiderivative. What will happen is instead of the power decreasing by 1 and multiplying, and the original power multiplying the constant or the coefficient in the front, what's going to happen is kind of the opposite. The power will increase by 1, and you will divide by that power increased by 1. And there could be some constant on the outside, which we'll represent with the plus c. So there are some rules here, as you see, that if you have a coefficient of k already in front and you want to find the antiderivative, you're still going to divide by is the power plus 1, and you will raise the power. Okay, and also the sum and difference rule. If you have two functions, say f plus g, then the antiderivative would be the antiderivative of f plus the antiderivative of g, and so on. So let's take a look at some of these. If we want to find the antiderivative of f of x here, well, here's what we know. The antiderivative will be equal to, so this x has a power of 1. It'll be x to the power of 2. So you'd have a 6. And since I'm raising it to the power of 2, I need to divide by that power I just raised it to. So I would divide by 2, which is equal to 3x squared. And so that would be my antiderivative in very specific forms. But there's one problem, and that is that we could have a constant. You might have saw that this included the plus c. There might be some constant that we don't know about. So to find, that is a antiderivative right here. All antiderivatives would be summed up by saying plus c. The antiderivative, so the capital F of x, would equal 3x squared plus some constant. And c represents a constant. So you could write it in either form there. All right, so here's part B, and again, it says find a antiderivative. So that means you don't have to have the plus c for f of x equals negative 6x to the power of negative 7. Now, let's walk through this one a little bit slower because we're working with negative powers. So we have negative 6x to the, and I'm going to do this in parentheses here, negative 7 plus 1. And it might help to see a number line. So here's 0. And if we want to go to negative 7, 1, 2, 3, 4, 5, 6, 7. There's negative 7 right there. We're starting here, but we're moving 1 positive. We're adding 1, which means we'll have the value negative 6. So, oh, and I need to divide here by the negative 7 plus 1. That's the rule. You divide by that same power that you're raising it to. So what does that mean? I will have negative 6x to the negative 6 divided by negative 6. Now, the division of negative 6 will simplify the coefficient of negative 6 in the front, which means my answer is x to the negative 6 power, or 1 over x to the 6. That's another way of writing that. So that is a antiderivative. Now, if you want to find all antiderivatives, you would need to include that plus c. And antiderivatives, I'm not spelling that right. That needs to be a v. There we go. All antiderivatives would look like this. F of x equals x to the negative 6 plus c, or f of x equals 1 over x to the 6 plus c. That's how you would write it if you wanted to find all, which is the better way of writing it like this. So that's why I'm writing it here, even though it just says find a, which means just for one of them, this would be like a constant of 0. There's nothing added to it. So with that, I'll let you try to find a antiderivative, which means you can have any constant at the end. Doesn't matter what it is. So you're really making sure that this portion, when you take the antiderivative, is correct over here. Remember, this is the same thing as saying negative 4x to the negative 5th. All right, I'll let you work from there. Pause the video if you need more time.